Welcome back to section 14.4, page 3. Let's try to do this problem. Suppose that to qualify for a management training program offered by your employer, you must score above 70 on a standardized test. Assume that the distribution of scores is normal with a mean of 65 and a standard deviation of 5. What percent of those who took this test qualify for the management training program? Okay, so the important things here are that we read that it's normal distribution, okay? The mean is 65, so that immediately tells us go ahead and put 65 right here, all right? And a standard deviation of 5. So that means when we're doing our counting, we're counting in terms of 5s. If the standard deviation were 2, we'd count in terms of 2. If it were 3s, we count in terms of 3. We'd add like 65 plus 3 is 68, and then 3 more, 71, and so forth. So this tells us how to count. So let's go ahead and before we even try to answer any of these questions, let's mark up our graph. So we know that we're going to say go up 3 standard deviations here, so divvy it up in about 3 equal pieces, and go down doing the same thing. Then we're going to count in terms of standard deviation, which is 5. So this is going to be 70, 75, 80. And going down, we get 60, 55, and 50, just by adding and subtracting 5s. Okay, now we've got our picture set up. Let's see what the question is asking us. It's saying that they want to know what percent who took this test qualify for the management training program. Well, what do you have to do to qualify for the management training? You have to score above 70. All right, so there's 70. So let's draw a line at 70. That's the cutoff point. Okay, so you have to have something to do with 70. It says above. So now we want to shade above. Okay, so all of this above here. Okay. So, how are we going to come up with that? Well, let's see here. We know that to get from the mean to 70, we've gone 1 standard deviation, right? So, if we look at this part here, let's draw another line here, because what we know is what's within 1 standard deviation, okay? So, what's within 1 standard deviation? This part here. Okay, let's just shade it, I guess, this way. Okay, let's see. Can you tell me what that percentage is? It's within 1 standard deviation. Okay, so within 1 standard deviation, which is 68% of the data. So we know 68% is here. Okay, let's think about what the whole thing is. The whole thing is 100%. So if we take, let me draw you some little pictures here. If we take all of this, okay, underneath the curve here, okay, so if we say the whole thing, okay, that is 100%. And then we subtract off what's in between here, which was 68%, what is that going to equal? Well, 100% minus 68% is going to be 32%. Well, what is represented in the shading part? Well, we have it here and here. It's this part. That's equal to the 32%. But it belongs here and here, right? So in our picture, what we just found out is this piece here and this piece here. Together, they make 34% or 32%. So what would be left for this? Well, we know that if we fold it in half here, half is here, half is here. So these two pieces have to be the same. So it's half of 32%. So this right here is 32% divided by 2, or 16%. Okay? So does that make sense how we found it? We took the whole thing minus the yellow, and then that would be the pieces left here that we've showed here. But we only have one of them that we're interested in. So half of 32 is 16. So that's the answer to the question, this part in here. So if you want, you could shade, this part is what we just found. Okay? And looking at this picture, that's this part right here. Okay? So we're going to answer the question. Say 16% of those, and I'm stealing the wording right here. Those that took the test qualify for the management training program. Okay, that answers the question there. All right, also look at your picture. Your sanity check is look at your picture. What you have shaded here, does it look like approximately 16%? It should. Okay, so let's move on now to the next problem. It says men's heights are normally distributed. Again, important. That means we're going to be using that 68, 95, 99.7 rule. With a mean of 69.5 inches. Right away, I'm going to put 69.5. Mean always goes in the middle there. And a standard deviation of 2.4. So this one's going to be a little harder. We're not counting in terms of fives. We're counting in terms of 2.4s. So let's go ahead and mark it. We know that we need 3 equal pieces. 1, 2, 3. 1, 2, 3. And we're going to be adding 2.4. So use your calculator for this. You're going to say 69.5 plus 2.4. What is that equal to? 71.9. Then add another 2.4. What do we get to? 74.3. And then add another 2.4. What do we get? 76.7. Then go the other way. You've got to take 69.5 and subtract 2.4. What do we get? 67.1. Then subtract another 2.4 and we get 64.7. And then last, we get 62.3. Okay? So now we have our line. Now we're going to see what they want. They say, a tiny home builder has designed its homes to have a door height of 71.9 inches, almost 6 feet. What percentage of men will be able to fit through the door without bending? So remember, men's heights are normally distributed, so we can use this picture. All right, so they're asking us, what percent of men will be able to fit through the door without bending? Well, we want to make sure that if they don't have to bend, then it has to be 71.9 inches tall. So 70.1.9 is what we're looking at. Okay, so let's draw our little bar there. Okay, now, which way are we going to shade? Well, who will fit through the door? If the door is 71.9 inches high, people who are taller than that are not going to fit through the door without bending. So it's the people who are smaller than that. So this is the way we want to shade. We want to shade this way. This is what we're interested in, this whole thing here. So you can be very short and fit through. Okay, it's these people that won't fit through. All right, so now somehow we have to figure out what this percentage is. Well, when we look at it, where have we gone? We've gone up 1 standard deviation. So we know how to calculate up 1 and down 1. So let's go ahead and do this. Let's go dash, dash, dash. And then we'll shade this part yellow. And you can tell me then what is included in that. Okay. So this right here is what percent? That is within 1 standard deviation, right? It's within 1 standard deviation. So that's the first number, the 68%. Okay, so 68% is within 1 standard deviation. But we need all of this here too. We want to add in all of this. It's also part of our shade. So how are we going to figure that out? Okay, well, remember how we did it last time? We said that if we have the whole thing, okay, so the whole thing, it's all of this, minus what's in that middle piece, That will equal what's in the tails. Oops, I'm drawing that way too far over to look like the other picture. So this piece is here. So the whole thing is 100% minus what are we taking away? The 68%. That's within one standard deviation equals, because that's what we have the yellow here. Has to remain? 32%. 100% minus 68, but that goes in that tail and in that tail. We just want this piece here. So what does it have to be? Well, this has to be 16 and this has to be 16, doesn't it? So together they're 32. So that means this piece here is 16%. How do we figure that out? We said it was equal to 32 divided by 2. Okay? So to answer the question, what would we say? We would say that we have, what percent will fit through the door? All of these, the 16 and the 68, okay, will fit through the door. So we were going to say 16% plus 68% equals 84%, okay? And that's the percent. 84% of the men will fit through the door without bending. Okay. So let's just talk really quickly about the difference between these two. In this one, we were just trying to figure out 70 and above. Remember what they were looking for. Okay, it was above the 70. So we just wanted this orange piece. Here we wanted both the orange and the yellow piece. So you wanted everything that was below 71.9. Okay, so we ended up adding those two pieces. All right, now this is dealing with something that we're not going to do. And I made these handouts so quickly that I didn't have time to alter this. So just cross that out. We are done with page 3.